9.7. It's Taylor's polynomials. So there's two definitions on this one. We have the nth Taylor polynomial for f at c. That one we have the p polynomial function of x. We have that is f of c plus first derivative of at c of x minus c plus second derivative at c over 2 factorial x minus c squared. And you keep on going all the way to the derivative, the nth derivative at c over n factorial x minus c to the nth power. Okay, depending on what nth number they tell you, what polynomial they want. They give you the function and they give you at point c. This one, Maclaurin polynomial for f is a specific Taylor's polynomial. Why? Because c is 0. So it's the same thing as this one before, but c is 0. So f of 0 plus the first derivative at 0, x, and then second derivative at 0 divided by 2 factorial, x squared, and you keep on going to the nth derivative over n factorial at 0, x to the n. Okay, so here we have, I'm going to do two examples, one with the Taylor polynomial and the other one with the Maclaurin polynomial. So here, this first example, right here says, find the first degree P1. And we have that tangent, our function f is tangent, and they're giving us the c at pi over 4. Okay, so we have a function. We need the first derivative because it's a first degree. So we're going to do derivative of tangent. Derivative of tangent is secant squared. Okay, so now we're going to plug into this function right here. We're just going to do the first two, the function, and then the first derivative. So P1 of x will be the function. Let me go right here. Okay. So it's going to be the function we have tangent of x and then we're going to have plus the first derivative, which is secant, square of it, this right here, times x minus c, or I guess, give me 1 second. Okay, so here I've noticed that the function says f of c. So right here, it's c, it is not x. Right here, we also have a c, and then we have x minus c. Okay, c is pi over 4. So it's going to be tangent pi over 4 plus secant squared pi over 4 x minus pi over 4. And then I don't know if WebAssign will allow this answer, but you can simplify. So tangent at pi over 4 will be 1. Secant squared at pi over 4 will be 2. And then we have x minus pi over 4. And I don't know if how far so we have 1 plus 2x minus, and then we have the 2 pi over 4. 1 plus 2x, and that simplifies to pi over 4. So right here, It's a minus, so right here is going to be a minus. Final answer, P1 of x will be 1 plus 2x minus pi over 2. Okay, second example. Example 2, find the Maclaurin polynomial. In this case, they gave me that the function f is e to the negative x. N is 5. So remember, we're going to have f of 0, and then first derivative, second derivative. In this case, I need to all the way to the 5. Okay, so that's we have the function, and we're going to do the first derivative. Remember, derivative of e to the x would be e to the negative x times the derivative of the top, which is negative. So I'm just going to put negative on the back. Second derivative, copy. Okay, so we have negative e to the negative x times derivative of the top, which could be negative again. That's going to change it to a positive. Third derivative, remember I need 5. We copy e to the negative x times derivative of the top, which would be negative 1. Changes to a negative again. Fourth, we actually put a little 4 on the top from here on, or next one will be a 5. Again, for here, copy derivative of the top, make it a positive. Then lastly, derivative 5, e to the negative x, and then that will be a negative. And now I need to plug in zeros for all of them. Okay, so I'm going to put f of 0. If I plug in a 0 over here, which e to the 0 will be 1. First derivative of 0 in this case would be a negative. Second derivative would be positive 1. Third derivative at 0 will be negative 1. Fourth derivative at 0 will be positive 1 again. And fifth derivative at 0 will be negative 1 again. Okay, and now let's plug it in to our function. So P5 of x, and I'm going to have to move this a little bit further up. Okay, so here I'm going to see my function. So f of 0, in this case, when we plug in 0 in the function, we got 1. So we're going to have 1. And then here is the first derivative, it's going to be negative 1, so it's minus 1. And it's going to be x, or 1x, plus the next one's going to be positive. And then we're going to have an x squared over 2 factorial. The next one's going to be a minus. That's going to be an x cubed over 3 factorial. Next one's going to be a plus. It's going to be 4th power. And this one's going to be a 4th factorial. And the last one's going to be second. It's crazy. So here it is. I don't know exactly where it froze, but these numbers are what's giving me the signs. And then the polynomial, it's telling me x. So first power over 1 factorial, x squared over 2 factorial, and then all the way to 5 over 5 factorial, and that's how we got those numbers. Lastly, we just need to simplify it. So 1 minus x, 2 factorial is just going to be 2 times 1, which is just 2. We have x minus 3 factorial is going to be 2 times 3, which is 6. x to the fourth, and then 4 times 6, 24. And lastly, oh my signs, be careful with your signs, careful with your signs. Minus power, and that's my final answer. Okay.